Okay, here's a physics problem in chapter 7 and 8. And it's a marble momentum problem. We'll call this problem number 1. This is just an example of what happens, how we can calculate the momentum of what happens in a collision of two marbles. And we're going to assume that the one marble we know is 40 grams and it's coming along the x-axis, so directly along the x-axis at 2.4 meters per second. And then it hits a little 18-gram marble that's just sitting there. And what we know is that the one marble bounces off at an angle of 20 degrees. So this is the bigger marble, the 40-gram marble. Bounces off at an angle of 20 degrees and at 1.6 meters per second. And because we know momentum has to be conserved, we can work out the trajectory, that is the angle and the velocity of the 18-gram marble, in order that momentum is conserved in the x direction and momentum is conserved in the y direction. So let me show you how you do that. We'll start off in the x direction. So let's look at just the x-axis. And it's going to be m1v1 plus m2v2. And so I'm going to start out with the 40 gram, and you don't have to worry about the units. So it's 40 times 2.4. So this is m1v1 plus m2 is 18, but its velocity is 0 because it's just sitting there. So this whole thing just goes away. There's nothing there. After the collision, well, we know that the 40-gram marble goes off at a velocity of 1.6 meters per second. And we don't know its momentum, but we do know that in the x direction, momentum is always going to be a cosine of the angle. So it's times cosine of 20. So this is the momentum, and then times cosine of 24 degrees will give us the the part of it that's going along the x-axis. And then over here we have to go plus, and this we don't know. We know it's 18, and all we know it's Vx. So it's the velocity in the x direction. So this whole equation is about the x-axis. So everything in here is right along the x-axis. If you wanted to, you could put in here, cosine of 0, because this marble is going right along the x-axis, but cosine of 0 is 1, so I usually don't put that in there. Okay, so everything here is along the x-axis, momentum along the x-axis. And when you solve this whole equation, you're going to solve it for Vx. So I'm going to do 40 times 2.4, and then I'm going to subtract, this is 0, so then I'm going to subtract 40 times 1.6 cosine of 24 degrees. I'm sorry, cosine of 20 degrees. I wonder where I get that 24 from. Cosine of 20 degrees. Okay, and then I'm going to divide that whole thing by 18. And that'll get me Vx. So I bring, this is 0, I bring this term over here, make it minus, and then I divide by 18, and that'll give me what Vx is. So let me do that on the calculator, and I'll put it in memory. So I've got 40 times 2.4 minus 40 times 1.6, make sure you're in degrees, times cosine of 20, put equals, and then divide by 18 and put that number in memory. So that's 1.99. So Vx is going to be 1.99 meters per second, and that'll be just in the x direction. So I put that in memory. And now we're going to do the same thing in the y direction. So the y coordinate, along the y-axis, what's the momentum has to be conserved along that axis as well. So this is, of course, now it's going to be 0 because the 40-gram marble is coming directly along the x-axis, so it's got no momentum in the y direction at all. And of course, the other one is 0 because it's just sitting there, it's not moving. And that's going to equal 40 times 1.6 times the sine of 20 degrees plus 18 times Vy. Okay? So what I'm going to do, same thing, I'm going to solve for y. I'm going to bring this, or Vy, I'm going to bring this over here. So it'll be negative 40 times 1.6 sine of 20 degrees. So this is the component of the momentum in the y direction. You just have to multiply by sine of 20. It magically takes care of that. Then I divide that by 18, and I get Vy. So negative 40 times 1.6 times sine of 20 degrees. And then I'm going to divide that by 18 and put that in memory. That turns out to be negative 1.22. So notice how it automatically takes care of the negative, automatically puts that negative in there, tells you, it's going in the negative direction, so it's going downward. The other marble was going in the positive direction, upward, so to balance the momentum, the 18 gram marble has to go down to the south, okay? All right, last step, we got to use the Pythagorean theorem to figure out what the velocity of that 18 gram marble is. So we do square root of 1.99 squared plus negative 1.22 squared. I wouldn't put the negative in there. And take the square root of that. So I've got negative 1.21 in my calculator already. I just square it, plus recall a squared, and then take the square root of that. And I get 2.33 meters per second. So it's going pretty fast. Not quite as fast as the marble coming in, but 2.33 is quite a bit faster than 1.6 is what the 40 gram marble is doing now. And then the angle is going to be arctan of Vy over Vx. It's going to be negative 1.22 divided by 1.99. We expect a negative angle because we know it's going to go down to the bottom of the page. So recall B is negative 1.21 divided by recall A, and do arctan of that, and I get negative 31.4 degrees. Okay, so that's how momentum is conserved. If momentum's conserved, this other 18 gram marble has to bounce off at the bottom 2.33 meters per second and negative 31.4 degrees. So that's pretty amazing, that we can figure that out. And it's because you're really good with vectors and you know how to do, use sines and cosines to calculate vectors. So it's a nice problem. It'll be maybe a test question.